one last section here in 3.4. We're looking around a bike wheel this time, and this bike wheel has a 1 foot radius. Again, we're still sticking with the idea of a unit circle, a circle with a 1 unit length for a radius. Okay. So this bike wheel has a 1 foot radius. It rolls to the left counterclockwise. Okay, so if we've got a flat ground here, and this bike wheel is going to be rolling to the left here. It first asks, what is the circumference of this wheel? Well, thinking about circumference, the definition of circumference and the formula that we use to calculate this is 2 pi r. Right? 2 times pi times the radius, or 2 times the radius, which would be the diameter. So we've also seen it as diameter times pi as well. But we're going to use this 2 pi r because we know that the radius equals 1. So if radius equals 1 foot, the circumference of this wheel would be 2 times pi times 1, which is 2 pi. Now I'm going to keep these things in terms of pi because pi is not an exact number, and if I kept on saying 3.14159 times 2 or 6.28, we could just call it 2 pi and we'd be much more exact, and that's a little bit easier, a little shorter too. Now mark the point Q where P will be after the wheel has rolled 1 foot to the left. So it's going to be moving this direction 1 foot this way, and then it's going to stop. But it's going to be rolling that 1 foot. I went ahead and traced this on some tracing paper, just a regular old page protector. And so this is that starting point P. And I want it to roll 1 foot. Okay. So if I think about it starting here, we could even just look at this like a regular old ruler, right? If that radius is 1 foot right there, where I want it to end up for my circle here, after it rolls 1 foot, just kind of keeping everything to scale, I would want it to go until right there. Okay? So I'm going to take this wheel and I'm just going to roll it along until I hit about that 1 foot spot right there. And so do you see about where my point would be? If we were to roll with it, that is about where our new point would end up. Okay? So when I slide that over, we're looking at about right there. So I'm going to put that mark on my paper. Right? And I want it on that circle a little bit less than the second spoke. So right about here is the point that they're asking us to mark, point Q. I could also look at it this way, that this point, P, is traveling 1 foot around the circle. So starting there with that 1 foot measure, it would be like using this like a measure, and we get it pretty close right there. Right, looks like it'd be even closer to the line than where I have it. But if I took that 1 foot line and kind of bent it around, that's what we're looking at. Okay. So we marked the point Q where the P would be after the wheel has gone 1 foot to the left. Be prepared to explain your reasoning. Well, this is 1 foot. This is 1 foot. In fact, in geometry, I think you already know what this is called. You maybe just need a refresher on it. That we call that a radian. Okay. So 1 radian is using the radius like a measuring, like a ruler, right? It's a measuring implement. It's a length that we have going on. So to mark the point R, where P will be after it has rolled 3 feet to the left? Well, we just said on the previous page that it would take about 3.14159 radii to get over here. How it's almost, but not quite. It's more than 3 radii, right? Remember I had my nifty radius kind of ruler around the circle that we were looking at. So when it has rolled 3 feet to the left, I'm going to again kind of use my nifty tracing paper like a ruler. Actually, I could even just use regular paper like a ruler, but that's okay. So here is 1 foot. Here is 2 feet. Here is 3 feet. And so I want to try to keep this nice straight line that is in scale, 3 feet, 1, 2, 3, starting with P and rolling it around. So I can't really roll that wheel, but I can roll these 3 radii around my circle. And I'm kind of trying to keep it pinpointed there. And you're going to see that as it rolls, bing, see where it gets right about here. Works better maybe with a piece of paper or a string. Actually, I could even just take this and just kind of bend it around like that. So maybe that's another way to look at it. If I start it with P there, and I bend this so that it matches around that circle, you can kind of see where my ending point is. I'm trying to get it to line up with that circle nicely. You can see where my end point is on my nifty kind of ruler guide. It's right about here. So right about here would be point R. So the angle in radians, how many radians does P rotate through to get there? Well, it would take 3 radians. The length of 3 radii. So what about after it has traveled pi feet to the left? Well, if this was 3 feet, I think you're already seeing where we're going to, that right here is actually going to be our next point that we're marking here, point T. Does it even have us do that? No, I guess not. This would be pi radians right there. So at half the circle, it's exactly 3.14, right? 3 feet plus 0.14 more feet. Okay. So point P, after the bike has traveled pi feet to the left, it will be, the answer to that question is, it will be straight across from where it started from. Right? So it will be right across the diameter. Well, what about 10 of those pi feet? 10 pi feet, how far would that be? Well, let's see. So it does tell us to mark those points on this circle. There we go. So straight across from where it started, we're going to call that point T. That's our pi. Because we have P, Q, R, O. Maybe we'll call that T. I already said it a million times. I don't have point S. That's strange. 10 pi feet. Well, if half a circle is 1 pi feet, another half of a circle would be 2 pi feet, and 3 pi feet, and 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 10 pi feet would put us right back where we started from. This would be back at point P. Right? Because if halfway across the circle is pi, then all the way around the circle would be 2 pi radians. And so we can even start thinking this as like, well, it takes 2 pi, that's one rotation. So 10 pi would actually be 5 full rotations. I don't know if it's going to ask me that. I don't think it will, but I'm not sure. And then it asks me about 100 pi feet. Well, 100 pi is just 10 times 10 pi. Or we could look at it as 50 times 2 pi. 2 pi is one full rotation around the circle, so this would be 50 full rotations around the circle. It would also be back at point P, the same starting point that we began. Except this time it's gone through 50 rotations. 50 rotations times each rotation is 2 pi, gonna get me back to that same spot. Man, oh man. Alright, one more question going on here. After traveling some distance to the left, point P is at its lowest location in its rotation. How far might the bike have traveled? Alright, so as this thing went around the circle, right, so as this wheel is rolling on the ground, right now this point is at its highest rotation. And then it's going to keep on rolling and it's going to get back to the midpoint. And then at some point it's going to roll down here and be at its lowest point where it's touching the ground. Okay, so as that wheel spins to the left, that point is rotating around and at some point it's going to hit the ground and be at its lowest. That would be where this point P has rotated here to this lowest point. We'll call that point U. Okay. At point U, we want to see how far has the bike traveled, and we want to explain our reasoning about this. Well, it has gone more than 1 pi, and it has not quite gone 2 pi's. Okay, so it looks like it has gone 1 pi and then another half of a pi. Okay, it's gone this half. And it hasn't gotten all the way around the second half of the circle. It only got halfway through the second half. So it has gone 1 full pi on the top. Maybe you want to sketch that idea that it's gone from here to here is 1 pi, and then from there to where we stop, where point U is, it has gone another half of a circle. So we can see that it has gone, let's see if we can think about how many feet it has gone. It's gone 3.14 feet to get here, and then another half of that pi. So it has gone 1 full pi and another half. We would call that a pi and a half, or 2/3 pi. I'm sorry, 3/2 pi. So by going 1 full pi and another half of a pi, that right there is a pi and a half, or 3/2 pi. If we think about it in terms of the whole circle, well, if it goes like the whole circle, let's get a different color so we can see what we're doing here. we could think about it, instead of not quite making it this full circle, but making it 3/4 of the full circle. Another way that we could also write it is that it went 3/4 of a full 2 pi circle all the way around. These two things mean the same, because if I take 3/4 and multiply it by 2, I would have 6/4 pi, which when we reduce that is 3/2 pi. But want to be familiar with it this way, that we've gone 3/4 of the way around the circle here. Again, lesson 3. It's in the books. Go get some practice.